Okay, so this is section or unit 6, practice section 3. And this is all about preserving distances, stuff like that. You can see the corresponding lesson if you need any more guidance on how to do this stuff. So let's see. Yeah, so we have a coordinate plane here and a set of vertexes. Right, and it says that JKL and JKL prime are shown on the table, and this is the pre-image. JKL is a pre-image, obviously, and we're going to graph these. Right, so J is -2, 0. This is J. K is -3 and 3. This is K. And then L is -1 and 2. And this is L. Alright, so I'm going to use a straight edge to connect all of them together here. Connect all these together. And the bell might ring here because lunch is almost over, but if it does, I'll just pause it and continue, pick up where I left off during my free period. Alright, so that is my pre-image, JKL, and that is my triangle pre-image. And then my image is going to be JKL prime. So J is going to be 2, 0. Looks like this is going to be a reflection. 3, 3. 3, 3. And then 1, 2. 1, 2. Yep, so this is going to be a reflection just based upon the X and Y comparisons of each point, a reflection across the Y-axis. And that should be fairly intuitive to everybody here by now. If it's not, go back and look at Unit 4. Alright, so that's going to be K prime. That's going to be L prime. And that is J prime. And it's reflection across the x-axis based upon the points because the y values stayed the same, but the k values flopped in sign. Okay, what type of transformation was this? Well, this was a reflection across y-axis. Okay, was distance preserved in this transformation? Well, yes, it was. Yes, and they're asking about the distances between each point here. That's what they're asking about. Distances between each point. So you can see that none of the distances changed. This was a rigid transformation. And during a rigid transformation, distances and angles are preserved. The length of the measures, the segment length measures are preserved. So because it was a rigid motion, that is the definition of a rigid motion. So the reflections, rotations, and translations, distances are preserved. Okay. So the next thing is saying that we're gonna dilate the prime value. I'm going to dilate the prime value by a scale factor of 1/2, centered at the origin. So centered at the origin, we're going to dilate it by 1/2, right? So our doesn't ask me to, but I'm going to write it down, x comma y of 1/2 x and 1/2 y. That's my algebraic expression for that. So what do I need to do for each one of these? I'm going to make JKL double prime for each one of these. And then this is going to shrink this triangle because it is a scale factor of less than 1. Right? So L is going to go from the y value for L is going to go from 2 to 1, and the x value for L is going to go from 1 to like a half. So half is like right here. So this will be L double prime. Right, so the x value for J is going to go from 2 to 1 because it's half of 2, and then half of 0 is still 0. So this is going to be J double prime. Okay, I'm going to erase this. This is my point of deflection or of dilation. And then K is going to be the same for both because they're both 3. Half of 3 in the y direction is 1.5. So it's like right here. And then half of 3 in the x direction is about 1.5, which is right here. So it's going to be right here. So let me so it's going to be right here and right here. So that means I'm going to be right about 1.5 and 1.5. It's right about there. So those are my two lines. Right? So if I did it right, I'm going to check it, just in case I don't have my marks right. Right, this is going to be K double prime. I'm going to grab like a blue marker here, and if I did it all right, these lines should line up with the origin. These lines should line up close to the origin, and it might be off a little bit, you know, because, and then these lines line up with the margin, with the origin, and they do. Okay, so that is my, so I did it right. Okay, so there's my dilation there. And the question is, was distance preserved? No, it was not preserved. It was not a rigid motion, and you can see that the distance from each line was is smaller. No, it was not preserved. All line segments shrank by K, which is the scale factor. Okay, we'll move on to the next one. All right, so we have this. Complete the following statements about the transformations of FGH. Okay, so we see that FGH here. This is the initial, and that's the prime. I could zoom in a little. Okay, and still read everything. Oh, there's the bell. I need to pause this. It's a good stopping point for this one. I'm going to zoom back out and pause. All right, so these are all pretty easy. I don't even know why this is its own section, right? But here we go. This is you can check out here that each one is the same distance from the y axis. So this is a reflection, and its reflection is a rigid transformation. So this does preserve distance. Okay, this one is, you can see that this was rotated from here to here. This one would have been rotated from here to here, and this one would have been rotated from here to here. So this one went from here to here. So if you go like, if you could just draw a 90-degree angle from each point, right, from the axis to each one, right, G right there, and then H. Those are all 90-degree angles, right? So you can see that this is a 9-degree rotation. This is a rotation, and it does preserve distance. Okay, this is obviously a dilation, and it does not preserve distance because it's not a rigid motion. Right, this is a okay, so everything is pointing the same way. So this thing moved this way and down. They all move this way and down by the same magnitude. So that's a translation, and it preserves distance, right? Because it is a rigid motion. Okay, and then we have one has two transformations. This is the first one. This is the second one. Let's see if I can zoom in so you can see it better. Yeah, first one, the second one. Okay, and then this is the third one. Because these say, you can't see it, this is H prime. This is the third one. The third one. Okay, so the first one is a simple translation over and up of each point, over and up of each point. And then you can see that this one, if I would, I can just like, the first one is a translation. So the first is a translation. The second one looks like a rotation. But if I'm not sure, I can always just grab a coordinate pair. So F is a bad one to grab because they're both the same. H is 3, comma, and H is 3. Let me zoom out. So H is 3, comma, or 1, comma 3. And H prime is 3, comma, negative 1. Right, so the XY comparison is Y, comma, X, and the X value became negative, so this is a clockwise rotation of 90 degrees. So that is a rotation, and it does preserve distance. Okay, so that is the section 3 homework. Pretty straightforward. So here's a hint. If it's a dilation, it does not preserve distance. If it's a rigid motion, i.e. the other 3 types of transformations, it does preserve distance. If it's a series of transformations, and one of those transformations is a dilation, distance preservation is lost after the dilation. Hope that helps.